Hello guys, welcome to another episode of Doing Math with Mathematica. I am your Mathematica buddy Fawaz, and today we're doing a problem in related rates, which is a subject I particularly found uh, a bit more difficult than other things to do, especially that you can't just rely on Mathematica with this one, nor a set equation. Rather, you need to mix your comprehension with your smarts and do some math with that. So let's go right ahead and do this question. The question says that a boat is being pulled toward a dock as shown in the figure, and they have a sketch for you. Usually they recommend that you sketch it so that you can visualize it. They already did that for you. So if the rope is being pulled at the rate of 1 foot per second. So as you see, the rope is basically representing the hypotenuse here. So the hypotenuse's differential over time, d of dc over dt, is 1 foot, or rather negative 1 foot, since it's decreasing, coming closer. And then it's asking how fast is the distance between the dock and the boat decreasing when it is 3 feet from the dock. So they want the differential of the x-axis, or the long, I forgot what they call these things in triangles. So let's go right ahead and do it. This is a Pythagorean theorem problem with 3 variables to work with. Usually you would have something like, say, x squared plus y squared equals a certain number squared. No, here it's going to be equals a variable squared. So let's go ahead and do just that. So it's going to be, let's stick with x and y since we're more familiar with them. Let's do our equation x plus y squared equals, and let's give this one the variable z squared. So this is how your equation is going to look like. We know that our y in this case is 3 feet. From, if you look at the picture, you can see that the 3 feet is written on the picture itself, representing the length of which representing our y-axis here. So let's do this. Let's copy our formula, put it here, and substitute the y for the given value of 3, so that when we do our differential, which you can use the dt equals, or the dt of, which is the differential total. It's just it's a variation of the derivative command. Instead of dt would give you this. As you see, with the power rule, x squared became 2x, 3 squared became 0, went away, and z squared is still that. So if we were to go ahead and, so what are they asking us for? They're asking us for the distance between the dock and the boat. It's decreasing by, so they want the differential of x. So let's go ahead and say solve. Take this equation, copy paste it here, and say solve 2x differential of x, which equals 2z differential of z over time, for dt of that set x, since this is what we're solving for, and you get this equation. So now you know that you're going to have an answer that looks something like the value of z times the differential of time of z divided by the value of x. So do we know our value of x? Yes, we do, because they're saying that when the boat is 3 feet from the dock, which represents this here, the x-axis. The x-axis is currently 3. The y is 3. We don't know the z just yet, but we know the differential of the z, which is 1 foot per second, and we're trying to find the differential of x. And since y is a constant, there is no differential for it. So let's go ahead and let's take this, copy it, put it here, and substitute what we know and what we don't know. Actually, pardon me, there's one thing that we need to do first. We're going to take our original equation, and we're going to try to find the value of z. So as we said, we know that the value of x is 3 from the question. This is what they're saying when the boat is 3 feet away from the dock, so it is 3 for the x. The y from the graph is also 3. So 3 squared plus also 3 squared equal z squared. Solve it for z, and you get this. So go ahead, take the value of z, substitute it here, and then the differential of z, we know as we agreed that it's being pulled at a rate of 1 foot, so -1. And we know that x is 3. So we go ahead and, matter of fact, we can take this out, put it down here, shift enter, and you get this number here, turn it into a numerical value. And I believe this should be the correct answer. Let's see, so 1.41, they want it to the nearest thousandth, so 1.414. Let's check, and our answer is indeed correct. This here was a video of how you can do this very particular related rates issue problem where you have all 3 variables. Thank you for watching, and I hope you enjoyed and learned something. Bye-bye.